It is important that you really learn these first three absolute value properties because basically they're going to tell you how to remove the absolute values. Anytime you have the absolute value of x equal to k, this can be rewritten as x is equal to k or x is equal to negative k. Whenever you have the absolute value of x less than some number k, this can be formed into a compound inequality of negative k is less than x is less than k. And in this third case, absolute value of x greater than k, you then can rewrite x is less than negative k or x is greater than k. It's these bottom two inequalities that you do not want to get mixed up, and most people have troubles with this negative on this third property. Okay, in this next problem we have the absolute value of w equal to 2, equal to 0, or equal to negative 2. In this first case, using property number 1, we have w equals 2 or w equals negative 2. So we have the solution set containing 2 and negative 2. In the second part, you have w equals 0, but writing or w equals negative 0 doesn't make any sense, so we just have the solution set 0. In this third case, you have the absolute value of w equal to a negative 2. You're not allowed to have an absolute value equal to a negative number, because no positive can equal a negative number. This here is not possible, and therefore our solution set will be the empty set. This first equation has an equal to with the absolute value, so the first thing we want to do is isolate that absolute value by subtracting 2 on each side of the equation. This gives us 4 times the absolute value of 2t plus 7 is equal to 20. We will then divide each side by 4. This will give us the absolute value of 2t plus 7 is equal to 5. And now we are ready to use the property up above. We can write the expression inside 2t plus 7 is equal to 5, or the expression inside 2t plus 7 is equal to negative 5. Now we have two separate equations to solve. Subtracting 7 from each of these, we get 2t equals negative 2, or 2t is equal to negative 12. Then dividing each side by 2, we get t equals negative 1, or t equals negative 6. And our solution set contains negative 1 and negative 6. In this next problem, we want to isolate the absolute value first, and we begin by subtracting 7 on each side. We get negative 1 equals the absolute value of 9z minus 3. But if we are observant, we notice that an absolute value cannot equal a negative, and so no answer is possible, and we have the empty set as our solution set.